Okay, so your question is how to find a differentiable function f such that f prime of 1 over x is equal to x over fx, right? Well, I think the first thing we should do is to explore the symmetry of the situation and thus plug in 1 over x for x. So cross-multiplying will reveal the symmetry better. As you see, when we cross-multiply here, we have these two very symmetric expressions, symmetric with respect to x and 1 over x. So now if you look very carefully, this looks a lot like the product rule. Except that you have to be careful because this is the derivative of f evaluated at 1 over x, so that's different from taking the derivative of f of 1 over x. By chain rule, this derivative should be f prime of 1 over x, but then also need to multiply with this minus 1 over x squared. Thus, if you multiply both sides here with minus 1 over x squared, we get an expression that is now ready to be used with this one below. If we add these together and use product rule, we have that the derivative of this product must be 0. So this product must be a constant, so let's call that c. So now that we got this new expression, let's try to substitute things back in. The idea is that we want to write everything in terms of just fx and f prime of x. Right, so we need to kill off all of the terms that have this f of 1 over x. So we write f of 1 over x as c over fx, and then we can plug it in here or here, the same thing. Now, if we indeed plug this into here, then what we get is that c times f prime x over fx is equal to 1 over x. But look, this is just the logarithmic derivative. And now everything becomes easy, because now the only thing we need to do is to kill off this derivative, which we can do by integrating. Now integrating this side just gives us log x, and because log is injective, or you might say 1 to 1, therefore fx must be equal to x to the 1 over c. Well, that doesn't really matter. The key point is that f of x is going to be a power function of x.